Okay, so it did just occur to me that there was one more item I wanted to talk about, and that would be what's it look like testing a known good starter solenoid. Again, I implore you to understand what you're testing when you're touching terminals like this. Are you touching the terminal that goes to the starter, or are you touching the terminal of the starter solenoid? There could be some corrosion in between the two, so just make sure you know what you're testing, just like the battery method when you go to test it. If I wanted to check voltage down to the starter motor, I might touch the terminal to the starter motor. You could also, of course, touch it down at the starter motor if you're familiar with all that and what you're looking at there. In this case, in today's case, it doesn't matter. We don't have much of a load across this thing, so I'm just going to probe right on top here, okay? And so this is all hooked up as the previous one was, and the ignition will energize the coil in this. That heavy magnet will slam to the top and connect these two connectors appropriately. And this will buzz because we will have continuity across these two terminals. So I'm going to go ahead and just probe there a bit. All right, so not only did you hear the slam of the starter solenoid, you also hear that we have good continuity across this device. Yeah, it's just beeping at me because I'm not making good contact with my probe. But that is a fair note. When you're doing this, you want to hold your probes reasonably tight to the connection. It takes a little bit more effort than you think it does to get a nice solid signal most of the time. Let's see, anything else? Let's talk about the scenario of if you run into something awkward. That, okay, I've tested continuity, this is all working, but it still doesn't want to work right. I can't quite figure it out. You can use your voltage setting to troubleshoot this. Now, let's say I were to probe this. This was all hooked up. You had 12 volt coming in. You should have 12 volt come out and go out to the starter motor when you push the starter button. But, hey, you know, my bike's still not turning over. It's turning over slow or something like that. If I were to probe the terminal going out to the starter motor, right? Or probe it at the starter motor itself, and I was getting like 8, 9 volts when I would hit the button, but I was getting a consistent, 12-ish volts on the input, but like 8 or 9 on like the output, we would know that there's like a bad connection inside of this. It's making enough of a connection to get a reading. It's not making enough of a connection to actually turn over the starter motor, which is like usually like a very heavy, current heavy device that needs a lot of good solid contact to work properly. If it was an LED or something, it would turn on all day. But the more current you flow through a connection, and the worse that connection is, the more you're going to have like a voltage drop. And that's why I'm saying like you measure like 8 during cranking on the output and like 12 on the input, for example. That would show you that there's something wrong either with like the terminals being corroded or something wrong internally on the starter motor. So that's what I was talking about earlier, a scenario where something is working but also not working. So, okay, cool. I think that covers everything. That should do it in most cases. You can apply all these methods to troubleshooting why your headlights won't work. You measure the voltage at the headlight when the headlight switches on. You don't have 12 volt, you work your way backwards. In this case, you could check, your brake wires. On this bike, this is probably a ground and this is a signal. And what that does is when you hit the brakes, it sends a ground signal back to a relay back here, back there, and that relay activates the lights. In a very similar sense, a starter relay is like a traditional 12 volt relay. It's just designed to handle way more current. Right? They're both relays. They both use a small input device, a small current device, something like a cheesy button like this or a switch or something, to be able to control a larger current device, say a starter motor, or in this case, technically your tail lights and things of that nature. I don't find those to be, they're a couple of amps, so I guess I'll consider them a high current device, right? So, brake switches like these control relay, and the relay controls the lights. So you may not have a problem at the switch, you might have a problem at the relay. In my case, the switch is acting up because it's a micro switch. and they get dirty from time to time and need adjustment and cleaning and so on, replacement in my case. Anything else electrically that we should talk about? I don't know. I mean, we could always get into the basics of it. Most bikes, they have some sort of alternator internal on the engine. You'll see a set of wires that come out of the crankcase. They're usually like all the same color. Like there'll be 3 yellows, and you can tell right there, there's 3 yellows. Those are 3 different AC signals. Now, we only talked about DC voltage today. Technically, most engines produce AC because of the way they spin and the way they work. They use a magnet to generate AC power. That AC power comes back here and goes into a device like, that's the CDI. I don't know if this bike has, yeah, there it is. Most bikes have something like that. It's a voltage rectifier regulator, I believe. What that does is it converts AC to DC, and it also smooths it out because AC is like a wave, DC is a very straight line. So you're kind of smoothing that wave into a straight line, plus you're regulating it to the 12 volts that we need. That probably, I think that produces something like 17 volts AC, and then that device in the rear fixes it for the vehicle. So you've got oddball devices like that on the vehicle. This is a CDI box. That's just for logic on the bike. It fires your spark plug at appropriate times and so on. We could take a device like this. So this is a water switch here. You'll notice that there's a pin in the center right there. There's a pin in the center, and then there's a pin off to the side. This pin off to the side is just carrying a ground. It's just grounding this device just in case the device wasn't already grounded. When this switch is satisfied, internally it will either pop in or pop out and ground from the case to this wire, this center wire here. So if you were to test this, since this is a water device, it's probably going to be something along the lines of like, oh, at 215, turn on the emergency hot water light on the dashboard to say, hey, we're overheating. That could be what this device does. Sometimes they're resistance-based, where they actually show you the temperature on the display. I don't think that's what this one is. I think there's another switch at the radiator that actually reads the temperature. I think this one's just an emergency temperature switch. It says if I get too hot, I pop out and I connect these 2 wires together. So in that case, this switch, its function is to create continuity between these 2 wires. If you wanted to see the emergency light on the dashboard work, you connect these 2 wires together and it would light up. If you wanted to test this switch, you would have to heat it up to its point at which it activates and then test continuity from the 2 terminals that it's popped and it's creating continuity between the 2 terminals. So that's troubleshooting like basic switches like that. A lot of your other switches are just on off. They should be pretty obvious. They should make some sense when you get into it. So, okay, I'll leave you guys at that. I've gone a little too far for what I wanted to do on this video. So, again, leave any comments, and thanks for watching.